Good morning, dear students. Good morning, all of you. How are you all? Fine. So this is a video of class 9, and in this video we are going to derive the chemical formula of some ionic compound. Okay, now there are also the covalent compound derivation is there, but here first of all we will derive the ionic compounds derivations. Okay, now so you can see ionic compounds are that kind of compounds which actually have positively charged also and negatively charged ion also. Okay, now and that positively charged and negatively charged ions which are called cations and anions. Okay, now so you can see that it is written over there. If I will write here X positive and Y negative, so this is a positively charged, X is positive charge, and that is known as cations, and this one is a negatively charged and that one is known as anion. So it is essential that while writing the chemical formula of ionic compounds you should follow some of the steps, then only you can write the chemical formula. Okay, now so first of all you can see first the symbol of cation and anion should be written side by side. Okay, now how I will show you, and the next you can read the valency is written down below their symbol. So if there I will write here, I will write that if I have to write some of the chemical formula, and we know the ions, cations and anions. So first of all we can write here, suppose if I have to write a chemical formula for potassium chloride. This is a ionic compound. How it is a ionic compound I will tell you. Okay, now this one is a potassium chloride. So that I have told in the previous video that if something is written on the right hand side, that means it is negative, more electronegative. So this one chloride should be the more electronegative, potassium should be the less electronegative, and you can see that potassium is on the left hand side. So potassium, the symbol, first of all you have read in that method how can you write the steps for writing the derivation of the chemical formula. You can see first of all potassium, how can I write? K. Okay, now potassium K. Then after chloride, and chloride is Cl. Okay, now chlorine it is. Then after you had seen in this one the valency is written down below their symbol you have written K and Cl, and just to that down potassium their valency, so chlorine their valency you must have to write. So potassium chloride you are doing and K, Cl I am writing K. So their valency, potassium valency is +1 and its valency is -1. So what it will do, you have written this one. Now the next method, till this K, Cl you should note down. Then next step we will do, and here you can see this one is for the polyatomic ions. How can you write the polyatomic ions? Should be considered on the whole ion. What does it mean? If I have written here SO4 2 negative, if it is written over there, that doesn't means that this 2 is multiple and 2 is actually operating and performing any of the operation with oxygen only. No, it will actually behave like this one, SO4, and here this one is 2 negative, means whole of the bracket is actually tell us that 2 can perform any of the operation with sulfur also as well as the oxygen also, and this 4 is there also multiply with 2, any of the operation. If adding is there, but in the bracket you know no, multiplication would be there from your math subject. So 2 will multiple with sulfur only and 2 will multiple with 4 oxygen only. So any of the polyatomic, this one is polyatomic, more than one atom is there, so polyatomic. So that one is written over there, and here you have seen that valency of a polyatomic ion should be considered on the whole ion. Here it is given, and second NH4 positive. So you can see that here I have written NH4 positive. This is a way of writing this positive, NH4 positive. So it doesn't mean that this positive is only on that one. It is considered to be as the whole polyatomic ion NH4 positive. This one, okay, now whole bracket. So now next thing, if the cations and anions have same valency, then these will be cancelled out. What does it mean? If I will show you cations and anions should have same valency. If I am talking about Ca has +2 valency. SO4 has -2 valency. And you had read that one, that if the cations and anions have same valency, then this should be cancelled out. In writing a chemical formula, you need not to multiply, you need not to divide, any of the operation, you need not to do that one. It is written simply CaSO4. Okay now, so if the same valencies are there, then this should be cancelled out. Then after, if cations and anions have a common factor in their valency, in their valency, then these valencies should be divided by this common factor. What does it mean? If I have written any of the element x, here 2 is there, y 4 is there should be the common factor 2, 4, and that their common factor is 2, so that all that subscript can be divisible by 2. Okay now, so 2 1 ja 2, 2 2 ja 4, so what it will give you the resultant? X1 y2. Okay now, so you have seen, if there would be the common factor, then that should be divisible. Okay now, with the common factor. If there are cations and anions have a common factor in their valencies, then this should be divisible by the common factor. Okay now, then finally crisscross rule is applied. What does it mean, crisscross rule? Okay now, so you can see here, if I have written x is a symbol of any of the element which is present in any of the compound, so I have written x, general one. Okay now, and here you can see it is written, its valence is +2, because you know +2 why I have written, because we have written that left hand side should be the electropositive and right hand side should be the electronegative. So if there is a +2 and -2, sorry, -2 I cannot write. Yes, why I have called that one -2 I have not write, because I have to show the crisscross method, and you know, if +2 is there, -2 is there, that should be cancelled out. So I have to take that example, that you will understand that one. So here I will write -1. Okay now, then it is written on the top, finally crisscross method. So x is multiple with this one and y is multiple with +2. X is multiple with the valency of y and y is multiple with the valency of x. So what it will give the result? It will give the result x -1 and y 2. But I am sorry to say that one, when you are writing this chemical formula, you need not to consider this minus plus valencies. You need not to consider that one. That means finally you can write x1 y2, and also 1 is not considerable, so the valency of and the formula of this one is xy2. Understood? So it is written here clearly, you can see. Finally crisscross rule is applied. According to this rule, when formula is written, then their valencies are exchanged and the charge is not mentioned. I have told you that charge you need not to mention. Okay now, so then after properties of ionic compounds are made up of positively charged ions which are called cations and negatively charged which are called anions. Here it is, you can write negatively charged, negative one. Okay now, this one is called anions. Ionic compounds have high melting and boiling point, as this is formed from the ions, cations and anions, so their bonding is very very strong, and for breaking that bonding you need such a huge amount of energy, huge amount of heat, and if the huge amount of heat you are using, that means obviously the thermometer temperature will going to increase, and due to that one it will show the high melting and boiling point. And then after, these compounds conduct electricity in aqueous solution. What does it mean? Yes, if I am talking about any of the ionic compounds, suppose for example NaCl I am talking about, so sodium chloride is there, that means that sodium chloride in the dry state, in the solid state, the ions will not break, and in the liquid, if ions are there, that means they are actually conducting that electricity. But in this one NaCl, no ions are there. So it is there for the reason in the aqueous state or in the molten state, it is considered to be as an electrolyte. What is the meaning of electrolyte? That can conduct, that liquid solution which can conduct electricity, that one is known as electrolyte. Okay now, and majority of ionic compounds exist in solid state. Yes, it is very true that ionic compounds are there and that exist in the solid state, but when you put into the aqueous solution or heating that one, it can convert its solidity to liquidity and then after vaporization. So you need to think about that one, all the properties of ionic compounds, you can read that one and you will understand easily. Thank you.